In today's video, we will be talking about measuring. After watching this video, you should be able to understand the basic units of the metric system, understand the difference between a fundamental and derived unit, and be able to estimate information about an object. So let's get right into it. The first thing I want to talk about is measurements. And a measurement is the comparison of an unknown quantity to a known one, which is referred to as a standard. So a standard is something that you are comparing a unknown quantity to. One set of accepted standards, and this isn't the only one, one set of accepted standards, and this one's pretty well accepted worldwide, is the metric system. And that's really what we're going to be focusing on in this class. The metric system has three basic units, and that is meters, kilograms, and seconds. And originally, the metric system was based on the properties of water, but now they've taken on much more extreme definitions to be more precise. And I'll talk a little bit about those. You don't really need to know each of the pieces that make it more precise, but just so you have some background information on where this is coming from. So the first thing I want to talk about is the meter. And the meter measures distance. And the meter is based upon the length of the path traveled by light in a vacuum. And so light is able to travel, it's basically how far can light travel in this amount of time. 1/300 millionth, basically, I'm rounding this up, 1/300 millionth of a second. So that's how far light will travel is a meter. And that's what it's based upon. The meter is based upon how far light travels in this much time. Okay, so that's pretty crazy. A kilogram is used to measure mass, and we can basically roughly say how many atoms make up an object. It's defined now as the weight equal to the International Prototype Kilogram. And basically what that is a chunk of platinum iridium in the International Bureau of Weight and Measures located in France. Okay, so there's this hunk of metal basically that says this is what a kilogram is, and that's what the standard is, and that's what it's based off of. But kilograms used to measure mass. The second is used to measure time. And back in the day, it used to be based off of the sun, how long a solar day lasted. And there was too much discrepancy with that. And so now it's defined as this duration of the periods of basically this radiation of cesium-133. Now again, you do not need to know this, but this is just how precise we're actually getting with our measurements. That way it's based off of the amount of periods that this radiation undergoes. So the reason why this solar day is no good anymore basically is because, just as an example, in 2011 there was an earthquake in Japan, and it changed the rotation of the Earth by 1.8 millionths of a second, or 1.8 microseconds. And so natural disasters would be changing time ever so slightly, and so we need something else to base our second off of, and so now we basically use the radiation cycle of cesium-133. Other units that are also included in the metric system would be the ampere, also known as the amp, and that measures electric current. And basically it's a measure of how many electrons are flowing past the point. So 1 amp equals 6.241 times 10 to the 18th electrons per second. This number really won't come up too much in first semester physics, but come second semester when you start talking about electricity, you absolutely will need to know what an amp is. The mole.
Yes, nice to mole you. Meet you. Nice to meet you, mole. Don't say mole. I said mole.
The mole is the number of atoms needed to equal the atomic mass number in grams. Now, frankly, in physics, we don't talk too much about moles, so it's not something that I'm real concerned with you being aware of, but if you're taking chemistry, this is something that will definitely come up in that course. So that is also included in the metric system. Kelvin is a way to measure temperature, and originally it was 1/273rd of the difference between absolute zero and the freezing point of water. So the freezing point of water was kind of this baseline for which the Kelvin scale revolved around. Now, with super accuracy, we have found that really it's 273.116th of the freezing point of water. So again, it's just showing you how these measurements have changed over time and gotten more and more accurate. So here's just a look at the 3 different temperature scales. There's the Fahrenheit scale, and you can see if it's 0 degrees outside in Fahrenheit, it's really cold. If it's 100 degrees outside in Fahrenheit, well, it's really hot. Where versus Celsius, if it's 0 degrees Celsius, it's fairly cold outside. It's not super cold, but it's fairly cold. And if it's 100 degrees Celsius outside, well, you're probably dead, okay, because that's the temperature at which water boils at. If it's 0 Kelvin, you're dead because that's absolute 0. And if it's 100 Kelvin, that's super, super cold, and so you're also probably dead. But you can, again, just see the comparison of the scales and how 0 in Fahrenheit versus 0 in Celsius versus 0 in Kelvin really does make quite a difference. The candela is a unit used to measure light, and it's traditionally defined as the strength of light from a single standardized candle from 1 meter away. So the amount of light radiating from a single candle a meter away. Now, with super accuracy, it's defined as the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 times 10 to the 12th hertz, and that has a radiating intensity in that direction of 683 watt per steradian. And if you want to know what a steradian is, it's an extremely difficult way to basically define a unit of area at a set distance. And as I mentioned here, basically all this, my head hurts, it makes your brain bleed. So basically what you need to know is a candela measures light, and back in the day it was traditionally defined as the strength of light from a single standardized candle a meter away. So centimeters, grams, minutes, those are all great, but you're going to need to convert those units to the standard metric units. So a centimeter should really be turned into a meter, a gram should be turned into a kilogram, and a minute should be converted into seconds. So you won't be using those in this class. You have to convert them to the standard units. A derived unit. Okay, so obviously there's more than just what I've mentioned so far. What are derived units? All other units are considered derived units, which basically means they're composed of 2 or more of the fundamental units. So everything I had mentioned previously was considered a fundamental unit. And so some examples of derived units would be like speed. When we measure the speed of an object in physics anyway, it's measured in meters per second. Whereas weight is measured in kilograms times meters over seconds squared. Okay, so you can see in these items, such as speed and weight, you have fundamental units, but they're in combination with another fundamental unit. It's not just meters or kilograms or seconds. It's a combination of those. So that's what a derived unit is basically it's composed of 2 or more of the fundamental units. Prefixes can be used to increase or decrease the size of any unit. And so some common prefixes that you guys should be familiar with would be nano, which it is abbreviated with a little n, and it's 10 to the negative 9th meters, or 1/billionth of a meter. Okay, so it's super tiny. When you're on the nanoscale, you're talking super small. And it's not to be confused with grandma, grandpa, or little boy. Okay? Micro, it's this little u, but it has like a little tail at the start of it. It's pronounced actually mu, kind of fun to say. It's 10 to the negative 6th, or 1/millionth of a meter. Okay, so it's small, but it's not quite as small as a nano. Okay, so micro is mu. Milli is 10 to the negative 3rd, or 1,000th of a meter. Okay, and you can kind of think of like a millipede. It's like a 1,000 legs. And centi, which is abbreviated with a little c, is 10 to the negative 2nd, which is 1/100th of a centimeter. So there's like 100 cents in a dollar. Okay, so 1 cent is like 1/100th of a dollar. Okay, so those are just some prefixes. Last but not least, I am a big fan of knowing approximations. And the reason why is because it helps you to know if you're on the right track with your answers. So for instance, 1 meter is about the equivalent of 1 yard. It's not exactly, but about the equivalent of 1 yard. And if you're wondering what is a meter or what is a yard, it's about the distance from your nose to your fingertip, or about 1 long step. Okay, so being able to kind of visualize these things, you know, saying like 10 meters is sometimes hard to visualize, but if you can think of 10 nose to fingertip distances or 10 long steps, that kind of helps you visualize what 10 meters might be. So these are some approximations I recommend just kind of being familiar with. 1 centimeter is about the length of your pinky nail. Okay, 1 centimeter is about the length of your pinky nail. 1 millimeter is about the thickness of a nail. Okay, so if you look at your nail and how thick it is, that's about what 1 millimeter is. 1 kilogram is equal to about 2.2 pounds. And if you can imagine holding a pineapple, I don't know how often you hold pineapples, but if you do hold a pineapple, it's about that. Okay, 2.2. 1 meter per second is about 2 miles per hour. So whatever speed you're traveling at, if it's in meters per second, if you double it about, that would be the miles per hour. So it's kind of a good idea to have an idea of what you're saying. So if you're saying a car is traveling 5 meters per second, that's about the equivalent of 10 miles per hour. This is just a funny picture that I saw on Google. This is the Long Island MacArthur Airport, and it's saying it's about 1 kilometer away. Well, a kilometer does not equal a mile. Okay, so clearly this sign is pretty messed up. So again, having just that appreciation for these numbers and what they mean is helpful, because as I mentioned up here, a kilometer is about a half a mile, so really it should be half a kilometer or 1 mile away. Anyway, thought I'd just share that with you. That takes care of this video. I'll see you guys next time. One meter per second is about 2 miles per hour. So whatever speed you're traveling at, if it's in meters per second, if you double it about, that would be the miles per hour. So it's kind of a good idea to have an idea of what you're saying. So if you're saying a car is traveling 5 meters per second, that's about the equivalent of 10 miles per hour.